Hello grade 11s. Today we assist the Chiawa community with some of the calculations for their new community centre. As a part of the centre, the Chiawa community has decided to build a swimming pool and a sports field that will be used for athletics, soccer and netball. Here is an informal plan for the layout of the community centre. They have sent an email asking for help. They need to calculate the number of kiloliters of water the pool will hold, the number of liters of water-resistant paint required to paint the pool with 2 coats, and how many square meters of grass to buy to cover the sports field. Well, we have a lot to do, so let's get started. Let's begin with the swimming pool and calculate the number of kiloliters of water it can hold. Remember, when we talk about how much water an object can hold, we are referring to the capacity of the object, and this tells us that we need to calculate the volume. To do that, we will need to use the plan of the swimming pool to see what its shape and dimensions are. Do you notice that the swimming pool is in the shape of a circle? But because it is a 3-dimensional object, we need to check if it is a cylinder. Looking at a 3-dimensional view of the swimming pool, we can see that it is indeed a cylinder with a diameter of 10 meters and a constant depth of 1 meter. To calculate the capacity of the pool, in other words, how much water it can hold, we need to use this formula for volume. Volume equals to the area of the base multiplied by the height of the cylinder. In this case, the base is a circle, and the area of a circle is equal to pi times the radius squared. So the volume of the cylinder is calculated by multiplying pi r squared by the height, or in this case, the depth of the swimming pool. Remember that the radius is equal to half of the diameter, so in this case, the radius will be equal to 5 meters. Substituting in the given dimensions and using pi as 3,142, we get the volume to be equal to 3,142 multiplied by 5 squared times 1, which is equal to 78,55 cubic meters. As you can see, this answer is in cubic meters, but the Chiawa community has asked us to give them the capacity in kiloliters. So we need to convert our answer to kiloliters. Remember that there are 1,000 liters or 1 kiloliter in 1 cubic meter. 1 meter cubed is equal to 1,000 liters, which is equal to a kiloliter. So 1 cubic meter is equal to 1 kiloliter. Therefore, 78,55 cubic meters is equal to 78,55 kiloliters. Realistically, swimming pools are not usually filled right to the top, but close to that. So we will send the Chiawa community the full capacity of the swimming pool. Let's move on to the next part of their request, which is about calculating the number of liters of paint required to paint the pool with 2 coats of paint. This means we must work out the surface area. We need to go back to the plan of the pool and check the dimensions again. The pool has a diameter of 10 meters and a depth of 1 meter. We are given the formula for the surface area of a cylinder as 2 times pi r squared plus 2 times pi r times height or depth. But this formula includes all the surfaces of a cylinder, and we first need to consider which surfaces would need painting. Can you see that the bottom of the pool will need painting as well as the sides? We won't include the surface area of the top of the pool because this does not need to be painted. So we need to subtract the area of one circle from our total surface area of a cylinder. The area of one circle is equal to pi r squared. So the formula we use to calculate the surface area of the pool is equal to 2 pi r squared plus 2 pi r times depth minus pi r squared. This gives us a final formula of pi r squared plus 2 pi r times depth. Using the given dimensions and this formula, we have now adapted, let's calculate the surface area to be painted. Using the formula for the surface area of a cylindrical shape and the given dimensions, we get the surface area of the pool to be equal to 3,142 times 5 squared plus 2 times 3,142 times 5 times 1. The solution works out to be 109,97 square meters. It is practical to round this off to the nearest meter so we can get 110 square meters. We do this because construction calculations are usually done in square meters. 1 liter of the water-resistant paint that the Chiawa community has chosen covers approximately 4 square meters with 2 coats of paint. The Chiawa community asked us to calculate the number of liters of water-resistant paint they would need. Let's calculate that now. We divide 110 square meters by 4 to find out the number of liters of paint required to paint the pool. This gives us 27,5 liters, which means the community should buy 28 liters of paint. Once again, we've rounded off to the nearest liter because paint is sold in liters. Remember to always round up and not down, so you can be sure you have enough materials. The final item that the Chiawa community asked for help with is the amount of grass needed to cover their sports field. Here is the plan of that sports field with the dimensions indicated. Do you think we need to calculate the volume or the surface area of the sports field to answer this question? We need to calculate the surface area to see how much grass we will need to cover that surface. Also notice that the sports field is 2-dimensional. It's impossible to calculate volume without a 3rd dimension. This sports field is made up of a rectangle and 2 equal semicircles. The area of a rectangle is equal to the length times the breadth, and the area of a circle is equal to pi times the radius squared. Why don't you try calculate the surface area on your own? The breadth of the rectangle is equal to the diameter of the circle, which is 63,654 meters. Subtracting the radius of each semicircle from the total length of the sports field gives us the length of the rectangle as 100 meters. When we substitute these dimensions into the formula for the area of a rectangle, we get the area to be 100 times 63,654. This gives us an answer of 6,365,4 square meters. Now we need to calculate the surface area of the 2 semicircles and then add these values to the area of the rectangle. The diameter of each semicircle is equal to 63,654 meters, which gives us a radius of 31,827 meters. Because these 2 semicircles have the same dimensions, we can just work out the area of a full circle and we will have the answer for both of them. Using the formula for the area of a circle and pi equal to 3,142, we get the area of the 2 semicircles to be 3,142 times 31,827 squared. This equals to 3,182,71 square meters. This gives us a total surface area of 9,548,11 square meters. Grass is only sold in square meters, so we can round this off to 9,549 square meters. We had to round the number up, even though we would usually round it down. We did this because if we round down to 9,548 square meters, Chiawa will not have enough grass. In fact, to be safe, we can even recommend to the Chiawa community that they buy 9,550 square meters of grass. These calculations will help the Chiawa community greatly. If you would like more resources on this section, go to our website www.mindset.co.za/learn. Remember to look at the tasks for this section in the Working with Measurement task video. Chiawa for now.